The cybersecurity threats in IoT are vast. Digital certificates can be used to protect the communication between IoT devices and cloud-based applications. We at Trusted Objects and Nexus Group have allied to bring about a certificate management solution to protect IoT devices from production to their use in the field. PKI works with cryptographic keys and certificates. You can think of the key and certificate as a digital ID card of the device that must be present to access a service. Each device owns a private key needed for this authentication. The private key must be stored very securely in the device so that it cannot be stolen and used by hackers. Let's first get an overview of a common IoT device lifecycle. Nexus and Trusted Objects technologies enable security at the device factory. A factory certificate is stored in the MCU, a trusted identity. The MCU is shipped to the IoT device assembly factory. The assembled IoT device hits the market and ultimately the owner and operator. The operator will want to connect the IoT device to an IoT application such as Azure, AWS, or Cumulocity IoT. However, the application must limit access to devices that are controlled by the rightful operator and exclude others. To express a device's authorization to access the application CA provisions another certificate to the device. The IoT application can now easily recognize the authorized devices with fine granular control of access permissions. Let's take a look at the factory provisioning process in more detail. Firmware is flashed into the MCU during its manufacturing. Trusted Objects' top secure programming solution makes the secure link to the MCU. For secure storage and use, TOPS programs Trusted Objects to protect software secure element into the MCU. Nexus Factory CA produces the factory certificate. TOPS programs the certificate and the private key in to protect secure storage. Now the MCU has a trusted digital identity that can be used throughout the supply chain and in operation. The following demonstration starts with a brand new device just coming out of the factory with a factory certificate. The IoT device intends to connect to, in this example, AWS IoT via MQTTS. Should the device connect using its factory certificate to authenticate, it will be refused as only the application CA is registered at AWS. The device needs to first contact the application CA. It connects using standard ESD protocol. The factory certificate is used to authenticate. The application CA issues an application certificate. Using the application certificate, the device can now connect to AWS. Encrypted and authenticated messaging can take place. The sensor's data can be published to the AWS MQTT broker and be displayed on the subscribing web application, here on the lower right. When the board is moved, the gyrometer data is updated. The 3 access values are published. Let's quickly summarize. PKI secures communication between IoT device and application. PKI works with certificates. Standard protocols like TLS can make use of them to authenticate and encrypt communication between device and service. The best place and time to provision a factory certificate to the MCU is in the manufacturing process. Trusted Objects, TOPS, and To Protect, and Nexus Factory CA are integrated to do that securely. The factory certificate secures the supply chain and allows authenticating the device in the field. An application certificate can be issued later in the field. The application certificate ties the individual device to the operator's instance of an IoT application and allows secure message exchange.